It's Mr. Z, and today we're going to go ahead and calculate some sum and differences while describing the restrictions of x and simplifying good old fractions. Let's go ahead and take a closer look. Last time we looked at these, and these had just regular old denominators where there were numbers. We're going to up the ante today, and we're going to look at algebraic factors in the denominator. So essentially, I just really want you to understand that even though there are no parentheses, I want you to imagine that both the numerator and the denominator are considered a group, and they have their own parentheses around them. All right, so I need a common denominator. I need the denominators to be the same. These denominators, this number is not the same as this number. Whatever they are, they're not the same. So without knowing what they are, I can actually force a way to find that they have the same in order to allow me to combine them. What I'm going to do is I'm going to multiply the fraction on the left, and I'm going to multiply it by x plus 3 in both the numerator and the denominator in order not to break math law. So they will have that complicated fraction is actually going to make it easier, minus 5 over x plus 3. Well, this already has an x plus 3, so I'm going to multiply it by x minus 2 in both the numerator and the denominator. Okay, now you can see that the numerators are different, denominators the same. Okay, that's good with my soul. Now I'm able to combine these guys. Before I do so, I am going to clean up the numerators. After I distribute the 2, it's going to be 2x plus 6 minus 5x minus 10. And they are going to have the same denominator. And I am allowed to switch the order. I'm going to just write it as x minus 2 times x plus 3. In this case, just to make sure that they are identical. I didn't break any laws. Remember, a number times a number is the same as if you flip it. 2 times 3 is the same as 3 times 2. Okay, when I combine these fractions, I just need to make sure if it's a subtraction sign that I distribute it to both terms because it is its own group. So it is going to become 2x plus 6, and then it's going to be minus 5x plus 10 all over the same denominator, x minus 2 times x plus 3. I'm going to clean this guy up, and it's going to be negative 3x plus 16 all over x minus 2, x plus 3. What I should have actually done in the beginning, I kind of got over easy, is look for my domain restrictions. X cannot be 2, x cannot be negative 3. This is going to make my domain of my x's from negative infinity to positive infinity. Well, negative 3 comes before 2. So that means that the domain, the numbers that actually work, are going to be negative infinity to negative 3, union negative 3 to 2, union 2 to infinity. Voila, I have my restriction, x cannot be 2, x cannot be negative 3, and I have a simplified fraction. Now, the reason it's simplified is essentially I took two fractions and was able to combine it into one. Hoorah! Let's look at this guy. Let's actually do it proper and look at my domain restrictions from the start. X cannot be negative 3. X cannot be 3. The reason being is if the denominator is 0, math breaks. So this is going to mean that my domain is my x's going left to right from negative infinity to infinity. Negative 3 comes before 3, meaning that my domain is going to be negative infinity to negative 3, union negative 3 to 3, union 3 to infinity. This is a fancy way to say all numbers work except for x being negative 3 and 3. That's where they're going to have a vertical asymptote. All right, let's get to the nitty gritty. Let's go ahead and turn this into one common fraction. What I'm going to do here is I see x plus 3, and I'm going to multiply by what it's missing. It is missing an x minus 3. So x minus 3 to the top, minus 1 over, well, it has the x minus 3. What is it missing? It's missing the x plus 3. In order to add it as math law, I need to put it in the top and the bottom. Now, distributing this guy is going to be an easy task. It's going to be x minus 3 all over x plus 3, x minus 3, minus x plus 3 over, and I'm going to just switch the order now just to make sure that they are actually common denominators. Remember, this minus sign needs to be distributed to both parts. It's going to be negative x and negative 3, which is going to result in negative 6. The x's end up canceling, all over x plus 3 over x minus 3. We combine two fractions into one. Hoorah. Oh my god, it's even more complicated. I have 3 terms. Whatever am I going to do? Well, let's look at our domain restrictions. X cannot be 4. X cannot be negative 2. X cannot be 1. When I look at this guy, my domain is going to go from negative infinity to positive infinity. Now I'm going to order this in order. Negative 2 is here, 1, and then 4. That is important because I'm actually only writing down my asymptotes that are created. So use 0 as a reference guide. There is an invisible 0 here, and you can use that to gauge. Negatives are to the left, positives are to the right. Let's go ahead and write our domain. Basically, this is a fancy way to say, hey, these are the numbers that work. And all of those numbers work from negative infinity to negative 2, negative 2 to 1, union 1 to 4, union 4 to infinity. All it is a scan left to right, and I'm just talking about the regions of space that work. Now, I'm going to go ahead and get down to the nitty-gritty and try to find a common denominator. And essentially what I'm going to do is a more complicated version of what we've been doing. I'm going to go ahead and take 1 over x minus 4, and I'm going to multiply by what it's missing. It's missing x plus 2 and x minus 1. It is going to be missing x plus 2 and x minus 1. The parts that it's missing, I need to multiply the numerator by as well in order to make it a lawful change. My next one, I'm going to go ahead and do the same thing, minus x. It is having an x plus 2, so I need to multiply by the other parts. So I'm going to multiply by what it's missing, x minus 4, x minus 1, and then repeat this for this last guy. It is x squared, so what I'm going to do is multiply it by what it's missing. It has the x minus 1, so I'm going to multiply by x plus 2, and then the x minus 4. All right, they have the same denominator. Yes, they're in a different order, but multiplication, you can change the order and have it be equivalent. What I'm going to do is I'm going to go ahead and just combine all of them into one fraction before I do the cleanup. So this is going to be all over x minus 4 times x plus 2 times x minus 1. This is to save some writing. Now, x plus 2 times x minus 1, I might have to use an area model on some side work, but this is going to essentially generate x squared plus x minus 2. Now, I am not going to go ahead and distribute all of this yet because I don't want to mess it up, but I'm going to go ahead and write minus x, and then I'm going to distribute the yellow and the blue terms, x minus 4 times x minus 1. The reason I'm not doing it all at one time is even I am fallible. X times x is going to be x squared. I'm going to go ahead and combine it, and I get negative 5x, and then a positive 4. Same kind of idea over here. I'm going to leave this part out, x squared, and I'm going to multiply the goods, x squared minus 2x minus 8. Now, before I do anything else, I'm going to go ahead and leave the parts the same. I'm going to distribute this x to get negative x to the third plus 5x squared minus 4x. Notice how the negative from this part had to be distributed to all of the terms. That was highly important. That is a way to make an integer error, to make all of this hard work a little inaccurate. And then I'm going to distribute x squared to get x to the fourth minus 2x to the third minus 8x squared. All over the good stuff of x minus 4 times x plus 2 times x minus 1. Now this is a matter of just combining like terms correctly. This is going to be the part where, hey, if I was successful in all of the previous steps, I should get to the right answer. However, this is finicky. I'm going to go from the greatest power to the least power. So I'm going to go ahead and start scanning it, and I see x to the fourth. Now I'm going to look at my x to the thirds. I see a negative, and I see another negative. So this is going to turn into a negative 3x to the third, combining the red and orange terms. Then I go to my x squares. I see x squared plus 5x squared, which is 6x squared. Minus 8x squared is going to be minus 2x squared. I'm going to keep on looking. I see an x. I see a negative 4x. Those combine to be negative 3x. And then finally, I see a negative 2. All over x minus 4 times x plus 2 all over x minus 1. If I wanted to shoot for the moon, I could use long division or synthetic division to try to identify if any of these denominators could be simplified. But for the sake of this course, I'm okay with this right here. The idea is that we were able to take a 3 fractions, and what was I able to do? Convert them into one convoluted fraction. I know you might be looking at it and saying, hey, the original problem looks a heck lot simpler. Yes, but the idea is that, hey, we're taking one fraction is more simple than 3. This last guy, factor on sight. Automatically build that muscle into your brain. X plus 2, and then this is going to turn into 2 times x minus 1 minus 2x minus 1 all over. And when I factor it using a factor square, it reveals x minus 3 times x minus 1. Notice in the original problem, it was like, I don't even know what to do. However, here you can see that the factor form reveals what you need to do to each problem in order to get a common denominator. For this first one, for x plus 2, I notice it's missing the green term x minus 3. So what am I going to do to the numerator and denominator? Multiply it by x minus 3 minus 2x minus 1. What is this missing? X minus 3, x minus 1. Oh, it's missing a 2. Time to clean it up. Oops. I actually forgot to do my domain restriction. My domain restriction is, well, x can't be 1. Here, x cannot be 3 or 1. So my domain is going to be negative infinity to 1, union 1 to 3, union 3 to infinity. All right, let's keep going though. So now this is a matter of cleaning up. Remember this negative right here, you do need to distribute it to each part here when you're combining it. So I'm going to multiply x plus 2 times x minus 3. Notice in all of these, never multiply the denominators out. We want them in factored form. However, in order to simplify them, we do need you to multiply using maybe a FOIL, or like I prefer, the area model. So I'm going to get negative 4x plus 2. Notice how I doubled each part and I applied the opposite to each term. This is going to be over a denominator of 2x minus 1 over x minus 3. Let's go ahead and combine this guy. X squared is going to be left minus 5x minus 4. This is going to turn to be 2x minus 1 times x minus 3. And I actually see something really cool here. X squared minus 5x minus 4. This is why we combine the numerators together, because sometimes a new opportunity to factor emerges from all of the chaos. I see x squared, I see minus 4, and I can identify that if I pick these factors, oh, thought it could factor out. Darn. Sometimes it will, sometimes it won't. I hope you can see that this does not match. It does not make negative 5x. It's always worth checking, though, if you're able to factor it again, because if something shares a factor, you can simplify it further. However, since we checked, we are good to go with our SOL, and we are done. So I hope this helped. Remember, the big idea, though, is that you are supposed to do the domain restriction right away. And if it's not factored, factor it by sight. That's it for now. Also, my shirt is awesome.